Good time-appropriate greeting to the people who are watching. Thank you so much for joining today. If we haven't hung out before, my name's Mark Mandel. Hopefully we're going to hook up and... Oh, we're going to hook up. I don't know. We're going to hook up some stuff, make some things happen. If you don't know me, you've never met me before, my name's Mark. Like I said, I do developer advocacy and open source work for Google Cloud. As you can see, I'm actually appropriately branded today. I've got my Google Cloud t-shirt on and I've got a mug on as well. How very exciting. So what are we working on today? Let's screencast. Let's pop over here. So we've been doing a lot of work inside of Agones. Agones is a platform that's open source for running dedicated game servers. Actually, I might even do a little show and tell. And what we've been doing recently is working on the auto-scaling parts of it in terms of the nodes auto-scaling parts. So if you're not familiar with Kubernetes, Kubernetes is basically an open source system for running, like as a programmatic interface for running processes across lots of machines. It does lots of other things, but like at its core level, that's what it's doing. It's just a programmatic interface, and we talk to it sort of declaratively. We pass it these configuration files. And I think actually, whatchamacallit, do I even have anything in it now? So I'm running a cluster right now, actually. So you'll see here, what I'm actually running is, so if I have kubectl, get nodes, I've got a 4-node cluster running. It's been running for a while. And I don't know if I actually have Kubernetes. I don't know if I have Agones installed. I do. I have a version, probably a development version I've been working on of Agones that's installed right now. That's up and running, and we'll probably overwrite that in a minute anyway. Okay, so we have that, and that's up and running. You know what? Let's start. So what I want to do is this, right? So we have these fleets of game servers, so we have like a whole bunch of them. And what I want to do is usually the way we've been doing stuff recently is basically organizing things so that it's easier, basically so that it leaves behind like these empty nodes, these nodes that don't have game servers on them, and we can kind of shrink those down as much as possible. And so what we've been doing is I've done work so that when you allocate, like when you have the fleet and you want to grab a game server out of that, it's called an allocation. When you allocate out of the fleet, it packs those allocations as tightly as possible. So basically it prioritizes the nodes that have the most number of game server processes running on them. So that's already done. I've done some work to kind of group game server processes together. They're basically the pods, right? These are the containers that are running. I've done that work. That's actually sitting in a PR. I'm waiting for, I just did that this morning. I need that to get reviewed and pushed in. So the last piece before we actually hook up the autoscaler that actually is an open source project that comes with Kubernetes itself that we're trying to take advantage of is when we have our fleets, we want to make sure that when we remove items from fleets that we do, we want to do the ones from we want to do the nodes that have the least number of game servers on them, so that basically, actually, oh, that's an interesting question. But yeah, we want let's look at it that way. Let's look at it that way, and we can work it from there. So let's actually, I'm going to start with a feature. Call it fleet scale down. Let's give ourselves a branch. Do I want to do a demo? So what, let's I have a bunch of make commands that are all my development tooling. So I'm gonna make a build of this and push this up to the cluster that we're running. It's a GKE cluster. We can actually go have a look at it. In fact, yeah, console.cloud.google.com. Here we go. Agones images. Actually, which project is it? That's running. No, I want Agones Mark. Thank you. Awesome. So if we come down here, so we have this cluster that we created here, test cluster, which is lovely. And yeah, there's not a lot on it. It's just a 4-node cluster. It's nothing particularly fancy. There we go, 4 nodes. The dashboard here is actually quite handy. We can see some detailed information about it. Like we've got like 4 CPU on them. We can see how much CPU has been requested, how much memory we have, and how much memory has been requested. I find we don't ever tend to get that close to memory, but CPU we tend to use up a bit. All right, cool. While that's happening in the background, it's going to build some stuff. What I want to look at is, let's look at some of the code before I do a bit of show and tell. because what we'll do is we'll spin up some fleets and stuff. So let's have a look. All right, so everything inside of here has what's called a controller. The controller basically controls, for lack of a better term, what happens to fleets. So let's dig through the code here. So fleets, we have a controller. Fancy that. And then we have basically a sync function. All right, so usually what happens is data goes into a queue. It's the name of the fleet as fleets change and things happen. And then we run this sync queue. This is basically the basic pattern, right? We have, here we go, like an event handler. And then we push stuff into the queue, which is usually the name of the fleet we want to do stuff to. So we have a small abstraction here with our own worker queue object. Here we go, blah, 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 sync fleet, blah, 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 perfect. Okay, so delete empty game server sets, upsert game server sets. Oh, interesting. Okay. This is, I have forgotten how my code works, but this is, so we have these things called fleets, right? And they have like a number of game servers inside them. And in fact, this might be, oh no, that's still going. Okay, cool. It's gonna take a little bit. And they, what they actually do behind the scenes, they have a layer of abstraction called game server sets. Game server sets are actually the ones that control how many game servers go up and down. They actually control the number. Now, the reason that there is actually really important, it's basically because when you do new deployments to your fleets, you can actually create a whole new game server set, shrink one, or increase the other, and boom, you're good to go. It's exactly how, if you've used Kubernetes, if you've used a deployment, it's exactly how deployments work. They use what's called replica sets. So we actually want to dig into here. Here we go. Here we go. So we add in queue, update func, we do all this sort of stuff. Here we go. Sync game server set. Blam. So when a change happens to a game server set, how do we know what to do with it? So we grab the game server set. If we have one, great. Now we're saying, okay, let's have a look at what our diff is. And say, okay, if we have sync more, right? And sync less. Here we go. This is where it gets fun. Okay. Oh, I just thought of something. All right, we'll get to that in a minute. So syncing less game servers. There is a spelling mistake here. All right. Really? Let's, we're gonna rename that because that's awful. While we're here. Yep, that's a good refactor. I'm kind of also hoping... Nope, I actually spelled it right in the test. Okay, fun. All right, sweet. Make sure that test still runs. Run in the background. All right, so so what do we do? So here, sweet, my test passed. What I do is I have some locking, which is fine. I just want to make sure that certain things can't happen while we are deleting things because, you know, race conditions. We grab all our game servers. We look through them and anything that is not deleted 0. Okay, so that's fine. Count anything that's already being deleted. Okay, so if we already have stuff actively being deleted, we don't want to delete more. That sounds reasonable. And then basically what we do is right now, we choose by random, which is not actually what we want. Which seems unfortunate. All right. What I feel like now, there's some fun things in this. So right now we just choose by whatever list we have, going down the pile as we have it. And, excuse me. And we just delete it, right? And so there's no prioritization. So that's fine for what it is now, but we need this to be different. Now, there's one other thing we will also need. So let me git commit, fix spelling mistake. There's one thing we do have to know. So right now as well, the other thing that we're doing is that we're defining these strategies for how we do scheduling, basically. So if we have a look at Agones itself, where are we? We go down here to advanced scheduling and auto scaling. Right, so we're basically doing two kinds of fleet scheduling optimization strategies, right? One that's tailored towards, like, if you're running in the cloud and you have a very dynamic environment, we're going to do what's called packed, which is basically we're going to try and shrink things as much as possible into a smaller space so that it's much easier to scale down, essentially, because that's the trickier problem. Scaling up is usually easy. You just add a node, that's extra space, yay. But scaling down, right, we don't want to delete game servers, that's bad. So we're basically going to try and make everything packed. Distributed is for if you have like a static set, like a static game server cluster, or a Kubernetes cluster, I should say. Say you're running on your own hardware and adding a new node doesn't really happen very often. So that is pretty much what we have now, right? Like, we're just kind of leaving things alone at that point. We're like, okay, that's fine. Don't worry about it. Just leave everything to be as distributed as possible, which is kind of what Kubernetes does out of the box, which is kind of cool, right? So we can scheduling distributed and scheduling packed. So there are two things then we need to do here. We need to, right, so here, this is fine. Sync less game servers, I'm totally okay with that. Except for the fact that what we need to do is, if it's in the packing strategy, then what we need to do is basically order these game servers in the right way. So, or at least get a certain number of them. And non-allocated ones too. Interesting. That's good. Okay, so the thought that I had, so right now, if I look at not a game server, but the game server set that we're currently working with, right? And I look at game server set, and I look down at our spec, I don't have any idea whether this is packed or distributed. No idea at all. But I have a PR that I'm working on that I'm waiting for to actually get submitted, that I submitted this morning, that does this work. If I have a look here and we look at my pull requests, here we go. Here's packed. And part of this work, I don't know if we're going to be able to see it very well in here. So packed, like we have the packed scheduling strategy is removed from fleet and moved out to somewhere else. I put it somewhere else. I don't remember where anymore. Where did I put it? Somewhere. But what I did, I'm just trying to see if I can find a good example of this. Where are we? Here we go. Yeah. So here, game server set, right? Like, so I've added this scheduling strategy all the way down. So it's gone from fleet, goes down to game server set, and then it goes down to, can't see my hands. So fleet, game server set, and then it goes down to game server, right? And so it goes all the way through. And it also means that if you wanted to use just the game server construct by itself, you could also do that too, and have that float through and react accordingly. So okay, yeah. See, and I pulled this out into its own scheduling component. So what I'm going to do is actually rebase my work against this. So I have this as a root. It does mean that I can't submit this as a pull request until this one gets finished. Which is fine. There's enough stuff in the queue right now that I'm not all that fussed about it. I need to go bug some people to do some reviews. But otherwise, cool. All right. So let's do that. Let's set myself up nicely that way. Get branch. What branch is it? I have a whole bunch of branches right now. I have a lot of branches locally. I need to do some cleanup. I think it's allocate priority from memory. Let's actually have a look. Actually, this will tell me. Master from pod affinity. Okay, nope, I was totally wrong. Pod affinity. So git rebase feature / pod affinity. Okay, sweet. So now I have that. I'm gonna push this up Fleet scale down. Just so that exists as a thing. Okay, cool. So now, all right, now we have scheduling. We have scheduling on our game server set, and so we can do stuff appropriately. So we don't need this here. So let's have a look here. I feel like what I want is... No, you know what? Actually, no, I take it back. So, okay. Now, I did some work also previously that I might be able to take advantage of. But I have a feeling I put it in here. Let's have a look. No, I put it in here. Here we go. Find ready game server for allocation is what it is with a given comparator. Right, so this is kind of doing the same work already. In that, we're counting up the number of allocated and ready game servers that exist. Also, per node, so we can find the short list to allocate from. Okay. Right, but here instead, they're actually tracking the best node, whereas what I actually want to do is track the worst. Oh, actually, best is relative, right? Best is relative. It's either positive or negative. So, count.ready greater than 0. That is still true. The other thing that this is trying to do is return back an individual game server. And what I need to do is... what's the word? What's the word I'm looking for? What I need to do is... my brain's just not working. Is find a set of game servers from the least populated nodes. Now, here is an interesting question as well, which is to say... here's an interesting question as well. Oh no, I do already do this. I already do that there. Oh, can I reuse this in any way, shape, or form? Maybe. Maybe I can, maybe I can't. I'm not 100% sure. The other fun question is, do I need to grab all of... So what? Okay, here's what I'm thinking. I'll just say it out loud because it's gonna make my life easier. What I need to do is delete all of these game servers that are on the least number of nodes, right? Which is cool. Now, what I could do is just find the node with the least number of items on it, or the least number of allocated game servers, and then just look at that set. Look at the ones that are on that node. And that wouldn't be terrible. And I could just do that. And then what would happen is I would delete stuff, and then it would pass back through again, and then it would happen all over again. And then the next process would then just delete another chunk and another chunk and another chunk, right? Like I'd kind of chunk through it rather than having to do it all in one go. It's an option. All right, I think we're just going to have to kind of try this. And I think I'm going to just write it again from scratch rather than try and reuse it, and then maybe come back and refactor. I think that's my better way. So, okay, first up is game server set dot spec dot scheduling equals packed. Are we still calling this stable v1 alpha 1? Ugh, that's gross. I think I changed my way I was doing this. I just want to have a quick look. I feel like I was changing. No, not an MD. Go away. I thought. Yeah, I am. I'm just calling it V1 Alpha 1. Okay, cool. And then we can delete the alias. Beautiful. All right, so I'm just cleaning that up while I'm here. All right, sweet. All right, so if that's true, what I really then need to do is reset list to being c dot. I could probably follow something like this. So find, or it's actually filter game servers on least full nodes. That's a okay name, I guess. List. Seems reasonable. What's in game server sets actually? List game servers by the. Interesting. Where does that get used? Yeah, it gets used in fleets as well. Interesting. Okay, that's a whole other thing. Okay, so we could go in there. Let's create this function. See how well it does that. We'll just call it list. Yep, beautiful. All right, so I'm just gonna dump that. Game server sets. Interesting. That's fine. That could actually have been fleet allocation.go then. I'm just thinking through naming while I'm doing it. Why is that import not pick that up? That's actually quite strange. But anyway, game server. Oh, because you call it stable. Because blah. Let's fix that. Boop. All right, cool. So I don't think I like the name a little bit. I think I might change the name a little. But anyway, let's filter to give meaningful. Returns game server in the order in which. Let me think about this actually. Let's do it the simplest way, which I think is in batches. Returns a list of ready. Do I just want ready ones? Ready or allocated. See, that's not gonna work either. Let's think this through. I'm just thinking this through and I'm thinking this out loud, which is to say that we have both ready and allocated game servers. Do I want to remove from the nodes that have the most or the least ready and allocated, or the least ready? And I think the answer is ready and allocated, because you're actually like, those I want to shut down too, and everything should just disappear from there. Okay. I think that makes sense, but we can't delete allocated ones either. So there's no reason to there's no reason to keep. Ah, man, this is tricky. Let's. All right, so. See, I'm redoing this work here, which is not great. Yeah. Count, Elgato game servers. Yeah, that all seems. So getting this here, map of nodes. See, here it does special work, right? This is kind of an optimization here where I'm already tracking allocated game servers, one for each node. This is where I kind of wish Go had better support for like collections and stuff. Make life easy. Or like iterators. Okay. This is what I'm thinking. This is what I'm thinking. So similar to this, we're gonna keep counts. It's one step at a time, right? Oh, I had a node count here. Yeah, convenient data structure. Yep, I can work with that. Again, let's just copy paste and then we can work things out from there. Now, what instead of like node counts is cool, but instead of allocatable game servers, we're actually going to track all of them. Potential deletable game servers, all for each node, which is an array of pointers. And this will be deletable. I'm sure my teammates of mine will have some opinions about how we can make this more performant, but let's grab this as well. We call this GS list. I can work with that. Don't worry about that one. And I also don't care about this. Cool. Okay, so if it's not already being deleted, track all the deletable game servers. So this is interesting, right? So we want the deletable ones. We only want the ready ones per node. So we can use this as a short list to delete from. Awesome. Awesome. All right. This is fun. Okay, cool. This is hilarious. Just thinking this through. Okay. So this becomes deletable game servers. Append. Yes. So, okay, so we're going to take, for each node, we're basically going to group them all by, as we go through and we count, we're also going to group them all in a map. Okay, sweet. Now, what I feel like we also need is we need a int 64 limit, which is the number that we could have left. We could probably actually make that an int, probably is fine. What's diff? Diff is a int 32. Okay, so diff, like that's the max that we're gonna need. Is that happy about that? That's happy about that. Yeah, that's all right. That's okay. Okay. So what I need now is the least. I need the least number of nodes. Sorted. Man, I really wish there were better collection constructs in here. So I have the node counts. Awesome. What I need next is I need a way to right. Yeah, if it's ready, then yeah, perfect. But actually, that's perfect. I just realized I did that, right? So if it's ready, then it goes in the queue. It goes into the pile. What I need to do now is actually sort it into. I need a set of nodes. And what I could do. Let's have a look. I wonder if there's a good way of doing this. Golang map into map values as array or slice. That's fine too. It's probably like. Unfortunately, no. Okay, so I can do that. I just need to loop them. All right, that's less. Golang map values as sorted slice or sorted array is fine too. Sort go map keys. Maybe. With the range loop, maybe I can. So maps in Go come out in a. That's what I'm looking for. Come out in a. Oh my god, my brain fell over in a random way, which is fine. Golang sorted map. Is that a thing? I don't actually want to do that. Yeah, there's some. Yeah, I don't really want to bring another dependency. That makes me sad. All right. That's an interesting question. Here's an interesting question. Do I have one already? So I am gonna throw Godoc up. Localhost 888. So here we go. Packages !m equals all. There we go. So like sorted. No, map maybe. Have a look if anyone's bringing in like a hash map or a sorted map. So just bringing up Godoc and having a look to see if there's any sort of no. It's not looking like it. It's not looking positive. Because if there was something already in my vendor directory that I could take advantage of, sorted map maybe. Nothing. Hash map. No. Sorted. No. Game server. What? Oh, I wonder if the index is not finished. Definitely have game servers. Okay, there we go. Yeah, see, that's there. That's not good. Okay, so I might come back to that. Maybe there is something I can do there. I'm just trying to think. Okay, that's fine. It's fine. That's fine. Packages. There's nothing special there. All right. Let's start with naive. I mean, like that's like the basic stuff, right? Like let's start with a naive implementation, and we can always backtrack and try and make it better. I need a sorted list of nodes, basically at this point. Now, here we go. Maybe I want to change up my node counts here as well. Let me think this through. So I have a map of string of node counts, and that's fine for this. The node name goes in, and I have a node count. Actually, why do I have two? Here's a really interesting question. Yeah, why do I have two data structures? That seems overkill. Because what I could do is actually have ready as an array of pointers to game servers, which takes care of this. Still don't know whether that type really should be outside this function, but anyway, let's worry about that later. Because then we don't have to do that. What we can actually just do is say node count counts node name equals dot ready equals append dot ready gs, right? And then actually, if we want to, and actually, what we really want is total. We don't care about the difference between ready and unready. We just want the total. So that should be total plus plus. So there's that. My dog has fallen asleep behind me, which is excellent. Okay, so this feels better. All right, so we're going through. We've got our counts. We have their name. We have the total. I don't know if I'm happy with the naming of these variables and what they do, but like we'll come back around to clean this up. And we have the total because that's what we actually want to sort by. Now, the other fun thing is I feel like we're going to need to store the name in here. Just because I don't think we have a choice. And I'm also wondering if we can cheat a little. So I have this idea. This is for fast lookup. Use a little bit more memory. But what we also do is we keep an array of it as well. It's going to get convoluted, but I have an idea. All right, so I put this in name string. Okay, counts equals a map array of node counts. Sweet. Node counts. Here we go. And name equals gs.status.node name. Cool. So that exists. And we're also going to say, here we go. We're going to call this instead. This is the count map. And then we're also going to have a count list, which is an array of pointers to node count. Because we're going to have to do this anyway. We're going to have this list so that we can sort on it. Like we don't have a choice. So let's just keep track of both. Append. This needs to be a variable. This should be node. Append to this count list and node. Okay, so we're gonna have both. We're gonna track both. Placing no slice stack relation. That is totally fine. All right. So we want both. And we're gonna track both as we go through. So sweet. All right. And then what we need to do is sort our nodes. we do that. Right, least to most. I think this is maybe getting a little convoluted, but I think it's gonna work. I think the theory here is gonna work. I think that's fine. Okay, we sort of least to most, and then we need to get ready game servers until we equal or pass a limit. Yeah, I think that works. I think this works. I think this works. I think this works. I think this works. We'll see if it does, but I have ideas, and I think this will work. All right. Oh my god, fun. All right, so remind me how to do Golang sorting. There's a new sorting package. Sort, thank you. Oh, go by example, that works too. Nope, boring. Yeah, sorting by functions, thank you. Nope, we don't need to do that. There's a new version to do that. Where are we? Example. Blah, 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 blah. Less swap less. No, boring. There's a sort slash version methods the slash type by age and sort. This is usually that technique. Yep. Right. The other way is you sort of slice with the custom less function, which can provide by closure. In this case, no methods are needed. They're ignored. Here we go. Perfect. This is what we want. Okay. Sort.slice. Node list. Beautiful. Nope. What is that? Count list. I still don't know if I like the word count. Count seems a bit weird, but we'll get there. All right. So count list dot total greater than count list j dot total. I think actually what I want is less than, because I want the least. And it is not happy with me for some reason. Why not? Cannot use func bool type func I blah 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 as type. What? That's happy. Sort.slice last function. It's a bunch of reflection, which is not the fastest thing in the world, but anyway, one problem at a time. Cannot use func int itj return less than type func. What on earth? What have I done? Reports incompatible types. Does anyone see anything that I've done wrong here? What time is it? Cool. I got some time left. IJ int. Let's take that away for starters. That is the right function declaration. Yep. All right, and if I just said return true, just for argument's sake. Nope, it is not happy. Why is it not happy? Cannot use type func. Func I. Agones game server sets int. What does it think int is? That's what it is. There we go. I had that in the wrong order. I was like, why is that all messed up? Okay. Return count list dot total. I dot total is less than count list j dot total. So that should put that in least to most, in theory, right? Okay. So say results. We might as well make array pointers game servers the size of at least diff limit. we might as well start there because that just makes sense, right? So that's a good start. And then for, so we'll have a return result. So we want to spit that back out. Now for underscore n in count list. See, I don't know if I like count list for that reason, but I'll just call item. Range. It's actually a node, right? Like I feel like it's a node. Results equals append result n dot ready dot dot dot. So I want to add them all, and then if len result is greater than or equal to limit, return result. So just stop processing at that point. And I think, in theory, that should work. Yeah, so if we don't have enough, kick them all off, that's fine. Which would be weird. Actually, it's not entirely impossible, right? It could be that you just have a lot of allocated game servers in your fleet and you scale down, you're just waiting. That's entirely possible. Entirely possible. So we need to like go through all the nodes and have a look. This sounds reasonable. Okay. I'm just gonna write a to-do. Fix up comments and review naming. Why has my to-do not been picked up? Usually it goes green. There it goes. Thank you. Okay, cool. Yeah, because I'm not 100% happy with it, but it's decent. Let's commit this. First pass at filtering out game servers. So that's a thing, right? Like that exists now here inside controller. Diff int 32. Why is diff an int 32? That's actually a really good question. I see. Oh, count int 32 0. Why did I use an int 32? Genuinely? No idea. Diff int 32. Oh, I know why. Because the sync value, the value that's actually stored against the thing, that's stored against the definition that comes through the YAML file is in 32, and that has to be in 32 because Kubernetes reasons. Okay, so limit already should be in 32. That's already one bug. All right, sync less game servers. Let's actually have a look at our controller test sync less game servers. Let's see if we broke anything. That's a good start. Did we break anything? Yep. Mismatch type, int and int 32. All right, cool. So let's fix up some of these. Int 32, let's... All test pass. Nice. Default fixture for here is nothing. If I do this though, apply GS set. Do you have an apply defaults? You do not have an apply defaults. All right, so scheduling is packed. Because that is the default. That is what's going to come through the most. I expect that will now fail, and it actually fails on a panic. Okay, so that's fun. All right, so this gives us something to work on for a little bit. It may not be perfect, but gives us our first set, and I'll add also to do write a specific test for this. That's good. Interesting. Apparently, for whatever reason, this is not indexing to-dos very well anymore. Anyway, that's fine. So that can show up. Update the scheduling doc. Oh, I think I left. Oh no. Oh yeah, it's there. Boop. Alright, cool. No, that's fine. My brain just fell over. Cool. Alright, so let's work out what we broke. And I think I have a pretty good idea of what I broke. And we want to make sure that everything still should work the way that we expected it to. Just that, where are we? Just that it should come out in a different order. Set state, no. What was I testing? I'm testing sync less game servers. There we go. Test sync less game servers, right? So this should still work. What do we actually do in here? So we create a fake controller. We create some game servers. Just set of type. All right, cool. We have a function that just creates a whole bunch of them. So 11 of them apparently. We make some unhealthy. We actually make some allocated. Mark some. Wow, I can't type. Mark some is allocated. There we go. That's better. Make the least one already been deleted. Sweet. We just make sure that they're set to what we think they are. We list them, blah, blah, blah. So list game servers by game server set owner, right? So we agree that we have them all. We sync less. Interesting. How... Sync less game server minus expected. What? How? Subtract one because one is already deleted. T count. Oh, where does count come from? I'm so confused. How does this work? Oh, I see. When we delete, we add pluses. Duh. There we go. That makes sense. Delete action. We assert that it's not allocated. Beautiful. Count plus plus. And then we should assume that the one is already deleted, and we've actually deleted all of them. That's okay. Got it. I'm with it now. Okay, cool. All right. So when we run this is gonna fail. How long we got? We got 5 minutes. I actually have a meeting, so I do have a hard stop. I have a pretty good idea why this has failed. I'm willing to bet if I go in here, it's gonna say that. Actually, that's not what I expected. Value memory just no pointer. GS set state does not equal allocated. That is not what I expected. I'll tell you what. Run with. That is not what I expected. Panic on controller 333. Inside sync less game servers. GS status.state. It's not equal allocated. Alright, well, I'll tell you what. Right click, let's debug it. Let's see what we have. Compiling. I've suddenly become a huge fan of like runtime debuggers. I've noticed this in myself. Whereas I swear I haven't touched these in probably 10 years. I don't know why I was missing out on them, but now I'm actually a huge fan. Here we go. Beautiful. All right, so we hit here. All right, so what I want to look at is our list. Perfect. And there's a bunch of nil values in here. And I reckon it's because they say my debuggers are so nice. We have a bunch of nil values in here, and that's because we specified there is 11 items in here. But we don't know exactly how many we'll have. Has a capacity of 10, so we can actually stop this. I don't care. I know what the problem is. The problem is inside here, right? We do all this work, and we make this thing that's a limit that's of a certain size. Going create slice with capacity. Usage in internals, or maybe even there, yeah. So they don't need to be, right, that's fine. Slice and create with it. Yeah, but how do I? Okay, here we go. Make functions a type, a length, and an optional capacity. Got it. Okay, here we go. So really what we want is a 0 length. Oh my god, I need to run in 2 minutes. A 0 length with a capacity of the limit. Try that now. Test now passes. Sweet. All right. Don't know whether or not it actually comes out in the right order. We need to write a test for that, but at least the test passes. And I learned something new. Okay, cool. So let's actually commit that to GST, get that -a commit. Fixes. Actually, we'll do one more thing. Go import /w package. Yeah. Fixes for capacity and panics. So push that up. All right, cool. I think I'm going to finish at this point just because I do need to run in 2 minutes, and I'm feeling like it's in a happy place, at least to a degree. So this, in theory, what should happen now is, we can get rid of that, is, where are we? So we sync less game servers. So we're like, if we're in the pack strategy, then we should get back a list of game servers that are specifically in the order from empty nodes going forward. So we should be emptying, we should be taking game servers from the most empty nodes as much as possible. There's probably some stuff we can do to optimize that a little bit, but we'll see how that goes. Thank you so much for hanging out with me today. Some of you floated in and out, which is totally cool. And I appreciate you doing so and spending time with me and stuff. Yeah, usual sessions are 9 a.m. Pacific. I need to look at my calendar to confirm whether I'm doing it next week, but I'll put the event in the event section below. I would look on my phone at my calendar, but I managed to do this yesterday. So I need to actually go to the office and pick up a new phone because I don't have one right now, and that's very sad. Otherwise, yeah, usually 9 a.m. Pacific. I keep threatening to do impromptu ones. I should probably do that more often because it's really fun. So follow me on Twitter at Neurotic, follow me here on Twitch, and you can catch all the recordings on YouTube as well at Mark S. Mandel. Thank you so much for hanging out with me, and yeah, at the very least, I should probably catch you all next week, but I will definitely keep things updated for you as well. All right, I'll catch you all later.